Welcome to qnawire.
So we're going to, for part A, apply the conservation of angular momentum. We know that momentum initial equals momentum final. And so we can say that essentially 0 is going to be equaling this 0 would be the initial angular momentum, and this would be equaling the moment of inertia for the wheel multiplied by the angular velocity of the wheel plus the moment of inertia for the platform times the angular velocity of the platform. And so essentially we can say that the angular velocity of the platform is going to be equaling the negative angular velocity of the wheel multiplied by the moment of inertia for the wheel divided by the moment of inertia for the platform. This would be our answer to part A. Now, to part B, if it is pointed at a 6 angle to the vertical, then the component of its angular momentum that is along the vertical direction would be, we could say that moment of inertia for the wheel along the vertical direction would be the angular momentum for the wheel along the vertical direction would be the moment of inertia for the wheel times the angular velocity of the wheel times cosine of 60 degrees. And so we can then say that the initial angular momentum equals the final angular momentum, and we can then say that 0 equals the moment of inertia of the wheel, the angular velocity of the wheel times cosine of 60 degrees, plus the moment of inertia for the platform times the angular velocity for the platform. And so again, we can say that the angular velocity for the platform would be equaling the negative angular velocity of the wheel multiplied by the moment of inertia of the wheel divided by 2 times the moment of inertia of the platform. This would be your answer for part B. Again, here the negative sign means the platform is going to be rotating in the opposite direction of the wheel. Of course, that applies to part A as well. And then for part C, if the wheel is moved so that its momentum points downward, then the person and the platform must get an equal but opposite angular momentum, which will point upwards. So applying the conservation of angular momentum, we are getting 0 equaling the negative moment of inertia of the wheel times the angular velocity of the wheel plus the moment of inertia for the platform times the angular velocity of the platform. And here, the moment of the angular velocity rather of the platform would be equaling the angular velocity of the wheel multiplied by the moment of inertia of the wheel divided by the moment of inertia for the platform. And as you can see here, the wheel and the platform will be rotating in the same direction. So this would be our answer for part C. And then for part D, say that because angular momentum is going to be equaling 0, if the wheel has stopped rotating, this means that the platform will also stop. So we can simply say that the angular velocity of the platform is going to also equal 0 radians per second. This would be your answer for part D. That is the end of the solution. Thank you for watching.